All right. Welcome to the first episode of the Aeroguy. Hats to my girlfriend for making this awesome logo. And today we have one problem in store. That is a reciprocating engine problem. So the problem, it goes like this. Using the following information, determine how many degrees the crankshaft will rotate with both the intake and the exhaust valves seated. Intake opens 15 degrees BTDC. Exhaust opens 70 degrees BBDC. Intake closes 45 degrees ABDC. Exhaust closes 10 degrees ATDC. This problem is a very straightforward problem, meaning simply asking how many degrees the crankshaft will rotate with both the intake and exhaust valves closed. Okay, we have three choices: 290 degrees, 370 degrees, 245 degrees. Now, right before we dive into the problem itself, and in order to solve this problem, we need to understand the motion and the dynamics between the piston and the crankshaft. And why do we have given in the form of degrees? What's the significance? Remember, in the discussion for reciprocating engines, we understood that the crankshaft, or the rotation of the crankshaft, determines the entire sequence or the timing of the sequence of the piston, of the movement of the piston and the entire engine. It determines the firing sequence. It determines the intake and exhaust valve sequence. Basically, again, to emphasize this, the crankshaft controls the entire sequence of the operation of the engine. Okay? So, in order for us to simplify this problem, again, we need to look into how the piston moves and how the crankshaft moves. The piston, it moves up and down. Due to the rotation of the crankshaft. The crankshaft, it rotates, in this example, it rotates clockwise. And this clockwise motion, again, dictates the up and down motion of the piston. Okay? So as an example, just to give us a quick overview of the motion of the piston, again, the crankshaft, as it rotates, the piston also moves. Okay? The piston is attached to the crankshaft. This is the entire crankshaft. And the piston is attached to the crank pin journal. The center of the crankshaft is your main journal. Okay? As soon as the crankshaft rotates, this crank pin journal right here also rotates about the main journal. So it basically forms a line. And this line, again, as you know, is called the crank throw. Okay, moving on to the sequence. As the crankshaft rotates even further, the piston moves down even further. The crank throw is now oriented in this manner. Okay, and then the piston reaches the bottom of its allowable downward motion, the crank throw is oriented now in this manner. Okay, we have a label for such piston positions. We call this position in the beginning, we call this as a top dead center. And as soon as the crankshaft rotates a few degrees after top dead center, the position of the piston is called after top dead center. Upon reaching a 90-degree rotation, after the 90-degree rotation, this position is what we call as the before bottom dead center. And finally, at the most bottom position of the crank throw, we call it the bottom dead center. Okay, there is a position after bottom dead center. We call it, not that one, call it British Broadcasting Channel. Just kidding. Okay, so what's after bottom dead center? Simply we call it, so after bottom dead center, we call it after bottom dead center. And upon reaching a 270-degree rotation of the crankshaft, okay, here we call it before top dead center. Then we reach the top dead center position again. Okay, so we are simply referring the degrees that the given or the problem has given to us is simply referring to the crankshaft rotation and the crank throw angle with respect with the vertical axis. The crank throw is basically the radius of your from the crankshaft to the crank pin journal, from the main journal to the crank pin journal, and twice the crank throw is your stroke. Again, the center is your journal. So let's simplify this problem even further. To solve this problem, since we have understood the dynamics between the piston and the crankshaft, we have to further simplify this problem by simply drawing the vertical and horizontal axis passing through the piston journal. Okay? And crankshaft rotation as represented by the crank throw movement is represented by this, can be represented by this yellow line. Okay? Right. So, let's pull up the problem again. So again, just read the problem. Using the following information, determine how many degrees the crankshaft will rotate with both the intake and exhaust valves seated. This problem, intake, let's represent intake. Intake is green. So intake opens 15 degrees before top dead center. Right? And it closes 45 degrees after bottom dead center. So the piston or the crank throw will have to rotate. Sorry. Crank throw will have to rotate 90 degrees during the intake stroke, and another 90 degrees. This time, after 45 degrees, the intake valve closes. So let me just color this green. Okay. After that 45-degree turn, we have reached 270 degrees. We are now at our compression stroke. Reaches top dead center. The power stroke. And after another 90-degree turn, 70 degrees before bottom dead center, the exhaust valve opens. Okay, continuing with the crank throw rotation with respect to the crankshaft, we have reached 180-degree turn, another 270-degree turn, and another 360-degree turn, or the first 360-degree turn. We have reached top dead center. And after top dead center 10 degrees, we have your exhaust valve closure. Let me just color this in a different color so that you won't be confused. Okay, so let's label each angles. Intake opens 15 degrees, bottom dead center, that's 15 degrees. Again, the crank at this point, during the intake stroke, we have what we call as a valve overlap, wherein both valves are open. The exhaust is still open at this point until 10 degrees after top dead center. After that 10 degree, the intake valve remains open. Intake valve, reaching 90 or 180 degrees plus 45 degrees, the intake valve closes. So, at this point, this is where we have both valves seated. So, let's measure that rotation. Remember, we started with the intake valve or the intake stroke, 90-degree turn. One valve is still open. Another 90-degree turn. One valve is still open, and that is the intake valve. And after 45 degrees, we have one valve, or the intake valve closes. So, at this point, both valves are now closed. It is now closed for a 45-degree turn, and even with a 90-degree turn, both valves remain closed. And during the power stroke, both valves remain closed for another 90-degree turn, and only after a 20-degree turn is when the exhaust valve opens. Remember, the exhaust valve opens 70 degrees before bottom dead center. Okay, so adding up all The crankshaft angle rotation, the crankshaft angles. At the moment both valves were closed, we get 45 plus 90 plus another 90 plus 20, we get 200. Sorry, that's 5. 9 plus 2, that's 18. Sorry, 9 plus 9. 18 plus 2, that's 20. 24, 245. So the correct answer is letter C, 245 degrees. Okay, so I hope that's clear for you. Again, the process first is to initially understand, or the concept for this problem, the foundation for this problem is your understanding of the motion of the piston with respect to the crankshaft. You also need to remember that the piston is not directly attached to the main journal of the crankshaft, but it's attached only at the crank pin journal. As the crankshaft rotates, the crank pin journal rotates as well, giving you the angle of rotation with respect to the vertical axis. And again, don't forget, it is the crankshaft that dictates the proper sequence of the piston and in overall the engine. That's all for this video. Thank you and have a great day.